All right, our next quadrilateral that we're going to talk about is rectangles. All right, a rectangle is still a parallelogram. Right? It is just a special type of parallelogram. It has some additional properties that a parallelogram does not. So again, three things we want to take away from this video: angle properties, properties of the sides, and then finding those missing angles and sides using the properties. All right, so in our first box here, we start with the most important is, since a rectangle is a parallelogram, it has all of those properties. So by all, they're kind of listed here, but it has the 5 properties of a parallelogram. Okay, so we have all 5 of those things plus 2 more, right? So plus some additional. So the first new property here is, in a rectangle, all measures of the interior angles are 90 degrees. So these 4 angles in our rectangle are going to be 90 degrees. All right. Some people may say that consecutive sides are perpendicular, right? That's another way that people will talk about the angles being 90 degrees. All right. The next one. In a rectangle, the diagonals are always congruent. All right, so if I draw these diagonals in, this A to C and this B to D, all right, what's a little different about this than the parallelogram is that we also know that AC is congruent to DC. All right, I'm sorry, AC is congruent to DB. The two diagonals are the same length. Now, what that does is that adds us something that's a little bit new. We know that they bisect each other because that's one of the properties from a parallelogram. And what happens now is all 4 of these little segments here are actually the same. So the diagonals here, when they intersect like this, they also form 4 isosceles triangles. Right, so these 4 triangles here, each of the little ones, they are all isosceles triangles. Right, and that's going to be helpful with solving for some different pieces of information on some different side lengths here. Last one. When a diagonal is drawn, we now have 2 right triangles. Right, we kind of know that because, again, in our rectangle, these are right angles, right? And then the diagonal here, that's always going to be our hypotenuse in the right triangle. So the key things here: a rectangle is a parallelogram, but it has these 2 additional properties. So it is a parallelogram, but it has 2 more things, right? And then using these 2 things, we're going to be able to solve some questions. So just like the last video, I got 3 examples for us to go through, looking at these properties and seeing what we can figure out. So first one, given that ABCD is a rectangle, solve for x. So again, when I see this word rectangle, that means I can use all of the properties, right? And the key property that we're going to talk about here, because these are angles, talking about these 2 angles here, is that angle D is a right angle, which is 90 degrees. Now, that makes this triangle a right triangle. And what we can do, which we know all triangles, the 3 angles must add up to 180 degrees. So we should be able to set up our equation just like we have in the last unit. We can put our line down the equal sign, combine our like terms, get 5x, combine 2x and 3x, subtract 110 from both sides, we get 70, 5x, and we come away with x equals 14. All right, question asks us for x, we found x, we can keep moving. So the property that you needed to know here, or the 2 things you needed to know here, was that in a rectangle, the angles are 90 degrees, and then angles in a triangle add to 180. All right, on to question 2. As shown in the diagram of rectangle ABCD below, again, when I see that this is a rectangle, that means I have access to all of the properties. All right, AC and BD intersect at E. If AE is x plus 2, and then BD, this whole thing is 4x minus 16. What is the length of AC? So we have to use two properties here. We have to use one from parallelograms, is that diagonals bisect each other. So I know that if this side is x plus 2, this side is also x plus 2, which makes this whole thing, if I add these two together, 2x plus 4. So that's the diagonals bisect each other from the parallelogram. The next property that we talk about is the rectangle property, that diagonals are congruent. All right, so we're going to use that. These two things are going to be congruent. So we have 4x minus 16 equals 2x plus 4. We can solve this. We can add 16 to both sides, subtract the 2x from both sides, and we'll come away with 2x equals 20, which means x equals 10. Now, the question doesn't say solve for x, it says solve for the length of AC, which we know down here, this is the length of AC. So we're going to take that 10 and plug it back in, which is going to give us 24 as our final answer. So again, two properties on this one. We got diagonals bisect each other, which comes back from the parallelogram, and then diagonals are congruent. That comes from our rectangle. All right, last one. Rectangle ABCD has a length of 12 and a width of 15. What is the length of the diagonals? So first thing, we got to draw this. And the key thing when you draw out quadrilaterals is that you go in order, meaning A, B, C, and D. Okay, so you always want to label your letters in order, right? In a clockwise or a counterclockwise direction. That's important. Then it wants to know what's the length of a diagonal. So we're going to draw one of these guys in here, which is fine. So we have our right angle here. We know that because it's a rectangle. It has a length of 12 and a width of 15. We know that these are also 15 and 12. So what we're actually going to do here is we know that this is a right triangle, and we practiced this the other day in class. If I want to know the length of the diagonal, that's going to be my hypotenuse. So we actually have to use Pythagorean theorem. This is how everything that we've learned in the past kind of starts to build in. As I said in class, the first thing I like to fill out is my hypotenuse. It's across from the right angle. And then after that, I can fill in my 12 and my 15. 12 squared plus 15 squared, if you put it in your calculator, is going to be 369 equals x squared. We square root both sides. Now, the question doesn't say how it wants us to simplify. So if you wanted to, you could put this in your calculator and get a decimal. If you do it in simplest radical form, we're actually going to get square root of 9 times square root of 41. And if we simplify that, we get 3 square root 41. All right, that might be a little confusing. It's been a while since we've done that. If you have some questions about that, please let me know in class. We'll go over that. We'll show you how to do it in the graphing calculator. All right, but those are our properties for a rectangle. Make sure you, again, studying the properties of a parallelogram so that the properties of a rectangle are only two extra things. All right, get on your practice questions for video 4 and get ready for that 5-question mastery check.